Okay, we continue number 22. 1 kg liquid heated using immersion heater for 20 minutes. Temperature of liquid can be increased faster by, so I can use the formula Q equals mc theta. And then the heat supply is PT equals to mc theta. Okay. So you want to increase the temperature faster, meaning theta equals to PT over mc. Okay. So what you do, you want to produce larger theta, meaning larger change in temperature. So you can increase the power, you can increase the time of heating, you can reduce mass, okay, or you can change the type of the liquid used. Okay, so in this case, given is here reducing mass of liquid in the container. So we have that one will increase the change in the temperature, or the temperature increase faster. 23. A hand dryer blows out hot air in 1 second. 75 grams of air enters the hand dryer and gains 2000 joule of heat energy. Specific heat capacity is given. What is temperature rise of the air blowing out from the hand dryer? Okay, so we use the formula Q equals to mc theta. Q is given here 2000. M is 75 divided by 1000. Convert to kilogram. Specific heat capacity 1100. Temperature rise is theta. So you can solve, you can get theta, the answer. So the answer is 24.2 degrees Celsius. Okay, number 24. Graph shows heating curve of a liquid. So this is the graph. Okay, what is the effect of heat absorbed by liquid between S and T? So you can see here no change in temperature. So at this point, latent heat is absorbed. So for latent heat, you can see the most suitable answer. Okay, this one is to break the bonds between the liquid molecules so that can change to gas. So you can see this is the melting point, this is boiling point. So at S, liquid form, then change to steam. At T, completely change to steam. So this one is latent heat of vaporization. Okay, so it breaks bonds between the liquid molecule, no change in temperature. Okay, number 25. Okay, there's a mistake here. This one should be 37. Okay. So at we have this one is the Gay-Lussac's law, because volume is constant. So we have P directly proportional to temperature, or absolute temperature. So we have P1 over T1 equals P2 over T2. Temperature must convert to Kelvin. So we have the first one is 200. Temperature is 30 plus 273 equals to the second pressure, and then 37 plus 273. So you calculate for P2, you will get the answer is 205 kilopascal. C. So number 26, displacement time graph of a wave. The wavelength is 6 centimeter. To make it clear, not very clear. So this is the wave. Okay, this is ST graph for wave. So we want to find velocity of wave. We have V equals to F lambda. So from this graph we can get period. Period T equals to time taken for one complete wave. So this is one complete wave. One crest, one trough is one complete. So you read here 0.4 second, meaning period is 0.4 second. Frequency is 1 over period. so equals to 1 over 0.4. So you get 2.5 hertz. And then you substitute here frequency 2.5 and then the wavelength 6. So you will get 15 cm second negative 1. So the answer is C. 26 is C. 27. Figure 27 shows wave with large amplitude are produced on a tight string when blade is vibrating a certain frequency. Number 27. The phenomenon is known as vibrator and vibrating. So this is a fixed end. So the energy will be transferred to the string. Number 27. Because the word large amplitude are produced, so this one is due to resonance. Number 28. So this is the wavefront and direction. Plane vibrator. So concept of reflection. Which physical quantity changes after reflection? Frequency, no change. Reflected angle, no change. Wavelength, no change. Velocity change, because there is change in direction. So once the wave bounce back, meaning direction change, so velocity change. Okay, number 29. A tilted basin containing water. Water droplets are dripping at a constant rate. So this is the surface of water. So water dripping from the urette here. So you can see different depth of water created. This is deep and this one is shallow. Okay, which pattern will be observed in the basin? So when velocity depends on depth. So V equals to F lambda. F is constant. So meaning F directly proportional to, lambda. V directly proportional to lambda. So meaning when travel from deep to shallow, speed decrease, so wavelength decrease. So at first in deep region, distance between two wavefront must be longer and then decreases. So the answer will be A. So you can see here the lambda here is longer, so it becomes smaller and smaller because approaching deep to shallow. Okay, number 30. Figure 30 shows a wave barrier. What purpose of gap between the wave barrier? So normally this one at the beach, this one to reduce amplitude, because when the wave spread out, it will spread the energy also to a larger area, so become less wavy area. Okay, so calm water is created here. Number 31. Interference pattern. Okay, distance between two coherent sources 1.5 meter. Distance between two consecutive loud sound. Also we can calculate from here, and this one is distance between two consecutive soft sound. Okay, so given here is between how many x we have here? 1, 2, 2x. So 2x equals to 4. Between 2 is x. So x equals to 2 meter. Okay. So what is velocity of the sound wave? So you want to calculate for the wavelength first. Lambda equals to AX divided by D. A is 1.5, X is 2 meter, D is this one, 10. So you get 0.3 meter. So you to calculate for velocity V equals to F lambda. Okay. I want to calculate for frequency. So F equals to V over lambda. So 340 divided by 0.3. Okay. So we get the answer is 1135 Hertz. Okay. So the answer will be B. 32. Figure 32 shows fringe pattern obtained when red light is used in the Young double slit. So which fringe pattern will be observed when red light replaced by blue light? So remember the arrangement: red, orange, yellow, green, blue, indigo and violet. From red to violet, lambda decrease. Okay, so you want to know which pattern will be produced. So the distance between two consecutive fringes is x. X equals to d lambda over a. Let's say d and a constant, meaning the x is only depends on lambda. If you decrease or change red light to blue light, meaning you decrease the lambda. When you decrease lambda, x decrease. So the fringes will look more closer to each other. So the distance between two consecutive fringes or consecutive bright fringes become shorter. So you have fringe separation x become shorter compared to this one. Okay, when lambda decrease. Okay, number 33, process mammography, human breast or early detection of breast cancer. Which electromagnetic wave used for this purpose? So this one we use normally is X-rays. Number 34 shows a light ray directed onto glass block. Which statement correct about light ray enters the glass block? So this is from this is the glass block. If you cannot see, it's a bit blur. So from air to glass, the speed decrease or bends towards normal. Okay, so what happened to the light ray? Light ray travels slower speed in the glass block. Number 35, observer looking at fish in the aquarium. So this is the boundary that's separate between air and water. Refractive index of water 1.33. What is distance of image of fish from the observer? Okay, we use the formula n equals to height of image or real depth divided by apparent depth. So for this one is the real fish. Okay, so we want to find apparent depth. So 1.33 equals to 12 over h. So h equals to 12 over 1.33. So we get 9 cm. So meaning the image is somewhere here. Distance is 9 cm. Okay. So now distance between the image and the person is 25 plus 9. So we get 34 cm. So 25 plus 9. Okay, so we get 34. Okay, number 36. This is the diamond. Light ray enters diamond, refractive index 2.42. What is the possible incident angle at point P? So you can see when travel at point P here, this is the light ray, so you can see total internal reflection here. If you calculate the refractive from the refractive index, n equals to 1 over sine c. So 2.42 equals to 1 over sine c. So you calculate for critical angle first. So you will get 24.41 degrees. So this one produce total internal reflection, meaning this angle here, theta, must be more than 24.41. Okay. So the possible incident angle at point P theta, you must find the value which is greater than 24.41. So this one will be the answer. Okay. So for number 37, correct relationship between U, V and F. So this is the graph. Okay. From the graph, actually the equation is 1 over V equals negative 1 over U plus 1 over F. This is coming from 1 over F equals to 1 over U plus 1 over V. This is Lens equation. So you compare with mx plus c. So y must be 1 over V. So this one is up. Okay. Okay. And then the gradient is negative. X is 1 over U. And the intercept is 1 over F. Okay. So this one is out, meaning the answer is B. You can see C here, intercept at y-axis is 1 over F. Okay, 38. So we have concave lens. Which point position the image position of the image for? Okay, so for concave lens, this one will produce virtual, upright and diminished image. So it will form here B, smaller object, smaller image. Okay, number 39. Okay, number 39. Arrangement of two convex lens for compound microscope. Which one statement is correct? So you can see from here, this is the focal point for the objective. This is the focal length for the eyepiece. So from here you can see the difference between the two lenses. For compound microscope, we can compare the focal length. FE is more than FO. So this one will cause power of the lens eyepiece is less than power of objective. Okay. So image of objective lens formed at FO. So this is wrong. Image of objective lens formed at F. FE. Image of objective lens formed between FO and FE. Okay. Image for objective lens formed between FE and eyepiece. So the image formed here. So you can draw, okay, so image form here. Okay, so it's between FE and the eyepiece. Okay, the image form there. So answer will be D. Represent concave mirror used by dentists to examine the teeth of the patient. For concave mirror, it always produces image which is virtual, upright, and diminished. Okay. So the image formed by concave sorry, this one is concave, right? You won't get confused already. This is concave mirror. So for concave mirror, image size of a characteristic of image form depends on the position of the object. So you need to memorize the position. U less than F, U equals to F. Okay, U between F and 2F. Okay, U equals to 2F, U more than 2F, U at infinity. Okay, so you have virtual, upright, magnified, virtual, upright, magnified at infinity. Okay, real, inverted, magnified, real, inverted, same size, real, inverted, diminish, real, inverted, diminish at F. Okay, so this one all the characteristic of the image form according to the object distance. So this one, which one is correct? So you can see 40. Number 40, we give the answer is A. Because this one, if the object is U less than F. So U less than F, so you have virtual, upright, magnified. Okay, in the mirror. So in the mirror means virtual. Real image must form here in front of the mirror. Okay, so answer is A. So that's all.